What is linear momentum? Linear momentum is defined as the product of mass of an object with its velocity. It is essential to find the force exerted by the object's motion. We can say that the rate of change of linear momentum will give us the value of force that will be exerted by that object when it crashes into another object, or the force that will be needed to stop it from moving. Linear momentum takes place in a linear motion. Let us study about angular momentum in the next section. What is angular momentum? The analog of linear momentum in rotational motion is called as angular momentum. The magnitude of angular momentum can be found using three quantities. These three quantities are mass of the object, velocity of the object, radius of the trajectory traced by the object in rotational motion. These three quantities are multiplied by each other, as a result of which we get the value of angular momentum. We shall see examples of angular momentum in the next section. Angular momentum examples. The angular momentum is the analog of linear momentum in rotational motion. The radius factor peeps in when we deal with objects following rotational motion. Let us see some of the examples of angular momentum that are given below. Ice skater. An ice skater spreads her hands to maintain stability while rotating on ice, then she come closer in order to increase the rotational speed. This is a clear example of conservation of momentum. Helicopter propellers. The helicopter propellers are so arranged that effect of one propellers cancels out effect of other propeller. This effect is the net centrifugal force which acts outside due to the action of angular momentum. Gyroscope. Gyroscopes are used for controlling the orientation of the spacecraft/aircrafts. They spin so fast that the force generated out of this angular momentum makes the gyroscope stand straight on its axis. Any deviation in this axis will mean that the aircraft or spacecraft is making a turn. Fan blades. Similar to the helicopter blades, fan blades are also arranged in such a manner that they will cancel each other's effect. We should note that the blades with smaller length rotate faster and the blades with greater length move slower. But the net angular momentum remains conserved. Rotation of Earth. Earth has an angular momentum of magnitude mvr, where m is the mass of Earth, v is the velocity of Earth, and r the radius of Earth. A top spinning. When a top spins, it keeps on losing its angular momentum due to friction and air resistance. A spinning top can be referred to as object having angular velocity. A person sitting on a chair and rotating it. A rotating chair is an example of angular momentum. Here we can also note that momentum will be conserved if the person sitting on the chair tries to spread his legs or joins his legs. The speed of the chair will be increased or decreased according to the leg's position, implying that the momentum is conserved. Rotating a luggage bag. We often get bored while waiting for our flights. Sometimes we start rotating our bags to pass our time. These bags will gain angular momentum once we start rotating it. Toys. Some toys have rotating elements in them, or they themselves rotate. Their rotational motion is possible mainly due to angular momentum that they have gained. Rolling in flight. When an aircraft performs rolling maneuver, it is supposed to have angular momentum. The direction of the momentum is perpendicular to the motion of the aircraft. Mixer grinder blades. The blades of mixer grinder rotate to cut the vegetables or fruits placed inside the grinder. These blades move as a result of angular momentum gained by them. Spinning a cricket ball. When we spin a cricket ball, the ball gains some angular momentum. This way the ball turns when it has impact on the ground. This happens due to force generated due to angular momentum. Swinging a bat. This is the most common example of rotational motion. Once the thread is subject to rotation, the stone tied with it gains angular momentum. Ballerina. A ballerina rotates on her toes. The hand positions decide the rotational speed of ballerina. If her hands are spread across, then the speed is less, and if the hands are closer to her body, then she rotates faster. Stone ties with a thread and rotating it. This is the most common example of rotational motion. Once the thread is subject to rotation, the stone tied with it gains angular momentum. Spinning a basketball. Some basketball players rotate basketball on their fingers. The basketball rotates as a result of angular momentum gained by it. Discus throw. A discus throw player rotates his/her hand in such a way that the discus also gains some angular momentum. This angular momentum is then transferred to a linear motion after getting released from hand. Hammer throw. Similar to discus throw, hammer also gains angular momentum after the player rotates his hands with hammer in it. The hammer attains linear momentum once it is released from the hands of hammer throw player. Cycling. The wheels of cycles attain angular momentum, which is converted to linear momentum of the cycle itself. This way the momentum is also conserved. Divers making a 360-degree dive. While diving, sometimes the divers make 360 degrees loop before entering the water body. This is an example angular momentum gained by the diver while jumping of the diving board. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.